It is about Liang-Barsky line clipping algorithm. Earlier we have seen Cohen-Sutherland algorithm. Now we are seeing Liang-Barsky line clipping algorithm, where we start with this parametric equation which says what are the values of x and y. X is x1 plus u delta x and y is y1 plus u delta y. Delta y and delta x are the difference between x and y positions of the two endpoints. Okay. Having known about this, let me tell you the I believe you remember what was happening in the point clipping. We had a point. We have just to see whether this point is inside the window or not. What were the condition? It should be in the range of x, and also the y value should be in the range of y. The same condition. Let me write it again. In terms of point clipping condition, what were the point clipping condition? We will elaborate a little and then you will see how it is faster. Don't worry. So what happens? The point, whatever x and y value. What are the x and y values? X and y values are this as well as this. Okay. So let me write these as x1 plus u delta x. This is the x point, and what is the y point? y1 plus u delta y. It should be in the range of x w min and x w max. Okay, and this should be in the range of yw min and yw max. Very easy to understand, right? These are the values of x and y of the line segments, and we are just saying that these x and y values should be within the boundary. No problem. Let me write it in a different way. We have these four conditions. Okay, so if you allow me to write it something like this, for all these four inequalities, okay, we are writing something like u pk is less than equal to qk. Okay, what is the value of k? K can range from 1, 2, 3 or 4. Okay, let me put comma here. What is happening? This is something. How is it related to this? Okay, let me tell you what are the value of k. It is going from 1 to 4. So you will have P1, P2, P3, P4 and Q1, Q2, Q3, Q4. So it is saying U into P1 is less than Q1. Okay. If we are talking about the first condition, suppose this is the condition. So here U delta x, U delta x, I am saying what will be the U delta x? It will be, let it go this side, right? Anyway, let me tell you what are P1 and what are Q1. Suppose here I want to find out from this inequality, I want to find out the value of this thing. I want to keep on the left hand side. What it will be? I will bring this u delta x on this side. It will be minus u delta x, which will be less than equal to, if this is going this side, so what will happen? X1 minus xw min. Am I correct? Is it okay? Anyone of you can respond. So here, for keeping this in this equation, u is already here. What will be the pk from here? U is already here. What will be the pk? Where is? Yes, minus delta x. And what will be the q1? Whatever is in this side. So it is x1 minus xw min. Okay. Similarly, you will be able to find out the value of P2, Q2, P3, Q3, P4 and Q4. These values are P2 is delta x, P3 will be related to minus delta y and delta y, and Q2 will be related to this, right? U delta x you want to keep this side, so it will be xw max minus x1, right? Xw max minus x1. Similarly for Q3, this condition, this is coming this side, so y1 minus yw min, right? Y1 minus yw min, and Q4 will be yw max minus y1. So how this can be helpful? I don't know if it can be helpful. Let us see. From these four inequalities, we have derived these four things: P1, P2, P3, P4, Q1, Q2, Q3, and Q4. Let us see how this thing will be helpful to us. Okay. So for any line, this was our clipping window. Let me draw a window. Okay, it is x min, y min and x max, y max. Any line which is parallel to this particular line, any line, this one or this one, parallel to it. Okay. So if line is parallel to this particular line, can you tell me what will be the value of delta x for this thing? Can you guess the value of delta x for this line? Let me tell you, delta x is x2 minus x1 only. This point will have x1, y1, x2, y2, y2. So what will be the delta x here for this particular line? Am I audible? So what is the value of delta x? You have to understand, if the line is horizontal here, and if at all it is horizontal, in that case the value of x will remain same. Okay, So if the value of x is same, in that case the difference of these two will be 0, right? Oh yeah, sorry. Definitely what you are saying is correct. In this case delta y will be 0. In this case, if it is horizontal to this x axis, in that case x is gradually changing, however y remains constant. So the difference between y values is 0. Okay. However, we cannot determine this thing. Oh, that's why you were silent, huh? Okay. So definitely you cannot find a delta x. However, for delta y you are able to understand that the y values are constant. So the difference is 0. Similarly, any line, if at all it is parallel to y axis, in that case y values are changing, and in that case you will find that delta x is 0. So any line, if you are able to find P1, P2, P3 or P4 any value to be 0, then directly you understand that this particular line is parallel to any of the boundary of your decision this thing clip window. No problem. Now also you have to understand on which side it is. How will you determine on which side it is? Let us think about these values. What do you think if it is somewhere these values, when we are thinking about P1, P2, P3 and P4, they might be representing any one of the 4 boundaries of your clip window. Can you guess? K is equal to 1, this part. P1 is related to the left boundary. P2 is related to the right boundary. How do you understand? Related to the x value. It is on the minimum part, and this is on the maximum part, right? So if this is the x values, this is x minimum and x maximum. So P1 is related to the left boundary, P2 is related to the right boundary. Similarly, P3 is related to the below boundary or bottom boundary, whatever you call, and P4 is related to the top boundary. No problem. Now what you have found till now is not helpful till now, right? What you have found is either delta x is equal to 0 or delta y is equal to 0. In that case the line is parallel to any of the boundary. So does it help? So if at all it is found that it is parallel, delta x was equal to 0 for this particular line, so it is about okay, it may be this one, P1 or P2, any one of them. Okay, now you have to think about q values. Okay, now this q value, this is x1 minus the minimum value. Okay, let us think about the x values. For this line, any x1, whether it is this one or this one, this x1 value of any in point, if we do x1 minus x min, min of the window, right, x1 minus this min, what will we get in this coordinate system? x1 this value minus this value. Can you guess? You can guess in the terms of positive or negative. We will get a positive value or a negative value for this particular line. This is our x1 and this is our xw min. So you have to tell me x1 minus xw min. Am I audible? Not audible, eh? Okay. About this particular position was on this line. On this line we got delta x is equal to 0. For P1 we calculated and we got here P1 value 0. Then we tried to find out Q1 value. In this Q1 value we found that it is negative, x1 minus this xw min. It was x1 was smaller and xw min was bigger. So the difference was negative. In that case, since the value of Q1 was negative, which was less than 0, if Q1 was less than 0, in that case what we do? We will leave this line, we will consider that this line is outside, totally outside the window. Okay. Now we are considering this particular line. In this line we started with P1 only. The P1 value for P1 was, the difference of x was already 0, no problem. So it says that it is parallel to Q, this one, left boundary. Then we try to find out Q1 and this value of x1 is more than the xw min. So this value is greater than or equal to 0. In that case we understand that it is parallel to the left boundary, but it is only that it is on right side, I should say, on right side of the clipping window, left boundary. Okay. So from the first equation P1 and Q1, this one, we have derived that this line is on the left, it is on the right of this left boundary. The next equation is P2 and Q2. In P2 what we have found? Delta x. Again delta x, the value of delta x was 0 because the x value are same. So we understood that it is parallel to the right boundary. Okay, since it is parallel, now we are going for Q2. Let us find out Q2. Q2 is xw max minus x1. Xw max, yes. Now the presentation is okay. Here we are calculating Q2 xw max minus x1. What is the value of this particular xw max? It is somewhere here, and this is your x1. Here I believe x1 is looks like it is more, it is greater than xw max. Now you are saying xw max minus x1. Can you tell me the value is positive or negative? The value is Q2 is less than 0, right? Because this is a smaller value. Smaller value minus bigger value, it is less than 0. So, since it is less than 0, you can understand that the line is totally outside. Okay? This particular line is totally outside. So now, this was the story of those lines for which the pk values becomes 0. What about those lines for whom the pk values are less than 0 or greater than 0? Okay, let us think about the conditions where if the pk value is less than 0, then it is something like the line which is somewhere. If it is expanded, means extended, I should say. If the line is extended, then some way, sometime, it may come from outside to inside of the window. Okay, and if the pk is greater than 0, in that case the line may come from inside to outside. Very simple. So for any non-zero value of pk, we have to calculate something. Okay, for any non-zero value of pk, what you are doing, you will find the value of u. Wow. Here we have already seen something about the lines, okay, boundaries and the equations. Initially we started with P1, P2, P3, P4, Q1, Q2, Q3, Q4. These values we have noted down. Given the line, we first of all check whether if any p value is 0 or not. If at all it is 0, it is helpful for us. We understand it is parallel to the line. And if the corresponding q value is less than 0, then we understand that the line is totally outside. Otherwise, we understand that it may be inside. Or that if the pk value is less than 0 or greater than 0, then we will have to calculate the value of u. U values are something qk upon pk. So for each k, means for each boundary, we are calculating the u values. I am naming it r1, r2, r3, r4, which is definitely qk upon pk only. So we are keeping these r values with 0 and finding the maximum of it, and we are considering it as u1. We are trying to find minimum with 1, and keeping it as u2. So now we are trying to find out the comparison between u1 and u2. If u1 was greater than u2, then the line is completely outside, we remove those line, and otherwise we understand the line would be crossing the boundary somewhere, and we try to find out the x and y value using this equation, which is x1 plus u delta x and y is y1 plus u delta y. So this is how you try to find out these kind of you try to clip the lines. So here we have seen our Liang-Barsky algorithm, and in general this is more efficient than the Cohen-Sutherland algorithm. How it is efficient than that? Because now we have less number of this intersection calculations. Okay, only for these u values where these lines are there, for those lines we are trying to find out the intersections. Okay, so this is all for about Liang-Barsky line clipping algorithm.